In this example, we are given several linear equations. And for each equation, we are asked to find the x and y intercepts and then use those intercepts to sketch the graph of each line. So starting with the first one, if we want to find the x-intercepts, that is where the line hits the x-axis, or in other words, where the y-coordinate is 0. So we simply have to take the equation and plug in y equals 0. If we do that, we get 5x minus y, but y is 0, equals minus 2. And then I divide both sides by 5, and I get x is negative 0.4. So that gives us the x-intercept. And then if I want to sketch that, let's say that this is 1. So minus 0.4 would be right around here somewhere. Okay. So now we need to find the y-intercept. The y-intercept is the point where the line hits the y-axis, or in other words, where the x-coordinate is 0. So we need to plug x equals 0 into the equation. Plugging in x equals 0, that just leaves us with minus y equals minus 2, or in other words, y equals 2. So that's the y-intercept. So these are our intercepts, and sketching y equals 2 on this graph, I'm going to get a point right around here. Okay, so now that I have these two intercepts, I need to use those to sketch the graph of a line. Well, fortunately, if you want to graph a line, you only need 2 points, and we happen to have 2 points right here. So there's one part, and let's extend this out in the other direction as well. Okay, so there's a sketch of our line. Okay. In part B, the line we have in part B is this thing, 2x plus 3y equals 18. This is a linear equation in 2 variables, so its graph will be a line. If we want to graph it, one way, probably the easiest way to do so, is to find the intercepts. So we start by finding, again, the x-intercept, which is where y is equal to 0. Plugging y equals 0 into that equation, I'm left with 2x equals 18, or x equals 9. Okay, so this is my x-intercept, and I'll sketch I'll put it on my axes here in a second. First, let's find the y-intercept. Well, the y-intercept is where x is equal to 0. Plugging in x equals 0, I'm left with 3y equals 18, or y equals 6. So there are my intercepts. X equals 9, y equals 6. Plotting those on the graph, okay, let's say that each one of these boxes represents 2 units. X equals 9 would be right over here. So let's go ahead and label that. Y equals 6 would be up here. We'll label that as well. Now that I have 2 points, I can use those to sketch my line. And that's going to look like this. And let's extend it out in the other direction as well. Okay, there we go. That's a rough sketch of the line. Okay, part C. I need to, again, start by finding the intercepts. So we'll look for the x-intercept. Oh, excuse me, let me fix this. Okay. So we start by finding the x-intercept, which is where y is equal to 0. And I get minus 4x equals 0, or x equals 0. Okay. To find the y-intercept, just like before, I set x equal to 0, which is going to give me 2y equal to 0, or simply y is equal to 0. So this is sort of strange, but my x and y intercepts are both 0. So let's see what happens when I plot those. Plotting the x-intercept at x equals 0 gives me this point. Setting the y-intercept at y equals 0 gives me that same point. So it looks like this line only has one intercept, and that's right at the origin. This is unfortunate because we need 2 points to sketch the graph of a line. Fortunately, we can still get a sketch of the graph just by finding any other point on the line. So as an example, let's say we wanted to find the point on the graph where x was equal to 1. Plugging that into the equation that we were given, we would have minus 4 plus 2y is equal to 0, which is the same thing as 2y equals 4, or y equals 2. So the point 1, 2 is also on this line, and that gives us a second point we can use to graph the line. So our graph would look like this. Later on, we're going to find another tool that would allow us to graph lines like this, and that's calculating the slope of the line. Okay. And one last part, for example 1, part D. We have this line, 3y equals 12. Well, this probably looks a little funny right from the beginning because there's no x. So let's see what happens. Let's say I try to find the x-intercepts. Well, to do that, just like in the previous examples, I set y equal to 0. But if I do that, I get 0 equals 12, which is not a true statement. 0 obviously doesn't equal 12, so since I get a false statement here, this means there are no x-intercepts. Okay, well, what about the y-intercepts? Well, to find y-intercepts, we set x equal to 0. Well, as we notice, there's no x in this equation, so setting x equal to 0 doesn't really do anything. We are just left still with 3y equals 12, or y equals 4. So the y-intercept in this case is 4, but we don't have any x-intercepts. So let's say our y-intercept is up here, and we don't have any x-intercepts. So if there are no x-intercepts, that means the line that we are looking for never hits the x-axis, so it must be parallel to the x-axis. So our line will actually look something like this. And that actually makes sense when you think about it, because the equation we were given, it doesn't have an x in it, but it simplifies right away to y equals 4. So that means solutions to this equation are any point where y is equal to 4. In other words, any point where the y-coordinate is 4. And if I graph all lines like that, I'm going to get a horizontal line at height y equals 4. Okay, so that's it for example 1.